Want to see what I made? Nighttime, daytime, nighttime, daytime. It might not be very obvious in the light, but this is turned off when it is bright and it does light up when it's dark. This is a simple night switch using a photoresistor as a variable resistor and a transistor as a switch, basically an if statement. Let me show you how it works. Here is a schematic of the circuit that I built. And I'm going to explain this in two ways. One, slightly incorrect when I'm going to be talking about current because it feels a bit more intuitive. And the other is about voltage drops. So let me explain current. We have a power supply and conventional current is going to split into two paths. Which way will it go? Well, current can go across this 100 kilo ohm resistor, and then again, the path splits. It can go in this direction or this direction. In the dark, this photoresistor has super high impedance, high resistance, means significant voltage drop, means very little current. The current would prefer to go this way. Consider this an if statement. From the base to the emitter, if there is sufficient current going through, we can activate the current from the collector to the emitter. This means that the transistor switches on and current is allowed to go in this path as well. Closed loop back to the ground. What happens when it has low resistance? Well, think about it. The current goes this path, and this guy has very little resistance. If it has super less resistance, a lot of current is going to go through here, not sufficient through here. Close the loop and it never activates the transistor. Now, technically what I said was kind of incorrect because a transistor will activate when there is significant voltage drop. Think about classic electronics and classic electricity. Voltage has to be the same across all equipment in parallel. So that means the voltage across these guys has to equal across these guys. So if we drive the voltage drop by having a high resistance here, it increases the voltage drop across these two bad boys, which increases the voltage drop here, driving it past that 0.6 volt to get it going, and the switch activates. And the same is true when it is low resistance. If it's really, really low resistance, because this resistor is quite low in comparison, this is like, it goes about something like 10,000 ohms in the light. That means there's a really low voltage drop across this, which equals low voltage drop across this, which means the if statement does not get activated. The transistor cannot switch on. So this LED will only light up under the condition that the transistor activates from the collector to the emitter. I should have probably done this earlier. Collector, base, emitter. I hope you found that helpful. I do all of these things on Twitch, live on stream. We built the circuit with Twitch chat and designed it. We love to build things, try things, and make them as best as possible educational. Happy circuiting!